So as far as types of magnets, what I want you to take away is that there are two categories. There are the permanent magnets that are, remind you, those are ceramic tiles on an iron yoke. And there's the electromagnets. Those are the supermagnets. Of the electromagnet type, there are two types. The resistive, which means electricity is constantly needed, there's no supercooling agents involved, and the superconducting, that has that supercoolant cryogen in it that doesn't require as much electricity. As long as that liquid's in there, it is on and you can't turn it off unless you quench the magnet. So now let's talk a little bit about fringe fields. Fringe field refers to the magnetic field that is beyond the bore of the magnet. We need to try to contain the fringe field as much as possible. We use things called shielding to do so. Of shielding, there are two types of shielding. There's passive shielding and there's active shielding. Passive shielding. What we do is we contain the magnetic field with steel in the walls or even within the magnet. Active shielding is when you actually create a reverse polarity of a magnetic field. Think about it. When you put two magnets of opposite polarity next to each other, what happens? They push against each other. That's what active shielding does. You have the main magnetic field created by the bore of the magnet, and then you have a reverse polarity magnetic field that is trying to contain the main magnetic field. So let's take a look at how far a magnetic field would extend outside the bore of the magnet with the different types of shielding. In this image, the top left corner, if you notice it says 0.5 T. Those are your open permanent magnets, remember. They're not as powerful. The darker area closest to the magnet represents active shielding. This is where there is a reverse polarity magnet trying to contain that magnetic field. If that was not there and all we had was passive shielding, you could see how the magnetic field would extend out even further. And the final circle, the final diagram with a really light shaded area, is if you didn't shield it at all. No attempt whatsoever. Just let the magnet be the magnet. And you can see how much further out in square footage that magnetic field would extend. The same being said for the 1.0 Tesla, the 1.5 Tesla, and the 3 Tesla. Active shielding is very important. So let's look at the inner parts of the magnet bore. The outermost part of the magnet is where your shim coils will be. Remember, the purpose of the shim coils is to even out the magnetic field. The middle part of the magnet would house your gradient coils. Now, we're going to go into a lot more detail on gradient coils, but there's 3 sets, the X coils, the Y coils, and the Z coils. What they are designed to do is to literally change and torque the main magnetic field so that at one end of the magnet to the other end, in whichever direction that particular coil is accounted for, you actually have a weaker magnet on one side and a more powerful magnet on the other. This is going to help with spatial encoding as we get further along. And then finally, the innermost part of the bore of the magnet is where you have your RF coils, your radio frequency coils. These coils are responsible for transmitting the RF energy into the tissue and listening to it as it comes back.